All right, so a few days ago we learned about solving systems by using graphing, where we graphed two lines and we found where they crossed. Our other two methods are more algebraic. So solving by substitution and solving by elimination we would consider more algebraic rather than visual. So some students have a preference for that. Each method has its strengths depending on the type of problem. So graphing is really strong when you already have the y isolated on one side. You don't have to rearrange anything. But at the point where you're going to have to rearrange your equations to graph them, sometimes substitution and elimination are more worth your time or easier to use. So before we talk about substitution as a method to solve systems, we're going to talk about what is substitution in general. So substitution is whenever you plug something in. So in this example, we have 2x plus 3, and we can plug in a -1 for x. 2 times -1 would be -2. -2 plus 3 would give us 1. But this is the same as substituting when you plug something in. We're also going to need to use the distributive property in our substitution method. So as a review, when you distribute something, you're multiplying both. Sometimes students forget to multiply this second number. So this would be 6x minus 2. Same here as another example. We'd have -4x. And then -4 times -5 is a +20. I also see a lot of students leave this as a minus by mistake, but two negatives will give you a positive. All right, that -5 you should think of as a -5. All right, so you'll need both of these skills to do solving systems by substitution. So our goal is to isolate one variable in one equation to substitute into the other equation. So you're looking for at least one isolated variable. In this case, these y's are both isolated, meaning they're all by themselves on one side of the equal sign. So I have more than one, and that's fine too. This would be a good one to solve by graphing because they're both the y equals, as long as they fit on a graph, because that's also sometimes an issue with graphing, is they won't fit on your graph. I think these do, so it might be a good one to do by graphing, but I'm going to go ahead and show you how to do this type with substitution in case you don't like graphing. So here I have y equals -3x plus 10. Since this is equal to y, I can replace y with it. Meaning I could rewrite this as -3x plus 10 equals 2x minus 5. And now I don't have any y's and I can solve for x. If you have done this first step correctly, you should only have one variable. If you still have an x and a y, you've already done something incorrect and you need to fix it. Okay, so I'm plugging this in for y because it's equal to y, and now I only have x's left. And now I can solve for x. So let's say I add 3x to both sides. We get 10 equals 5x minus 5. Add 5 to both sides. And divide by 5 on both sides. So it looks like we get 3 equals x. Now remember, all of our solutions are in ordered pairs, so I still need to find y. To do that, I can use either equation and plug in 3 for x. So let's say I use this one, and I do y equals 2 times 3 minus 5. I give us 6 minus 5, which is 1. If I use this one, I should also get +1. -3 times 3 is -9, plus 10 is 1. All right, so you can choose which one you want to use. They give you the same answer. All right, so I'm just going to do a few more examples of this same process. In this case, I have x plus 2y equals 7 and y equals x plus 2. We are looking for an isolated variable. So in this case, y is already isolated. So I'm going to take what that is equal to, this x plus 2, and since it's equal to y, we plug it in for y. Okay. I have x plus 2, and then I'm plugging this in parentheses. I'm replacing that y with x plus 2. And now, before I can do anything else, I'm going to have to distribute this 2. So this will give us 2x plus 4. If I combine like terms, this will give me 3x. And now I need to finish out my 2-step. 3x equals 3. which makes x equal to 1. Now to find my y, because you need two numbers in ordered pairs. So this is x, we still need y. I'm going to plug 1 back in for x. So y equals 1 plus 2. That's 3. I could also have plugged it back into this one and gotten 3 as well. But this one seemed to be the easiest one since y was isolated. Okay? You will not always start with an isolated variable, is the problem here. There is still usually an easiest one to isolate, one that would be easier than the others. When I am looking at these two equations, this y stands out to me as being the easiest to isolate because it doesn't have a coefficient. 2x, 5y, 4x, I could still isolate those, but it would be more steps because they have coefficients in front. So to isolate this y, I'm going to move that 4x to the other side by subtracting 4x. So this is y equals negative 4x minus 12. And now I am ready to take this and plug it in for y in my top equation. So that'll give me 2x plus 5, and then in parentheses my negative 4x minus 12 equals negative 6. Next step would be to distribute. Combine like terms will give me negative 18x. Add 60 to both sides. Divide by negative 18. Okay, which should give me negative 3. Now I'm not finished. I still need to find my y, or vice versa. Sometimes you find y first and you need to find x after. You can use any of these three equations, this top one, this bottom one, or this third one after we rearranged it. You can use any of them. I think this one would be easiest because y is already isolated. I'm not going to have to move as much stuff around. So I'm going to plug in negative 3 for x, which would give me 12 minus 12, or 0. All right, one more. So on this one, again, there is usually an easiest variable to isolate if there's not already one isolated. I would say this x is the very easiest to isolate because it does not have a coefficient and it's positive. So y would be the next best candidate, but because of this minus in front, it would take one more step. All right, so I'm going to move this 2y to the other side by subtracting it. So we have x equals 16 minus 2y, or you could have negative 2y plus 16. Now I'm going to take this, since it's equal to x, it gets plugged in for x. So I'm going to have 2 times 16 minus 2y minus y equals 2. So at this point we will distribute. Combine like terms, and then finish out our two-step. So in this case, y is 6. In our ordered pair, y always comes second. So even though we found it first, it's still second in our ordered pair. I can now take this 6 and I can plug it into either of these or any of these three equations. The two we started with or the one we rearranged. The one we rearranged will be the fewest steps, but they will give you all the same answer. So here I have x equals 16 minus 2 times 6. 16 minus 12 gives us 4. Okay, you can always plug these back in to check your work. You could also graph them and see if you get the same answer. There's several ways to check your work. Another tool you might want to use So Desmos.com is the graphing calculator we use a lot. We used it for linear regressions, but if you just go to the normal Desmos.com, you can type in what you started with. And get an ordered pair out. Like this is 4, 6. So that'd be a good way to check your work. Now, you still need to be practicing these methods and not rely on Desmos to solve them all for you. It's a good tool to check your work, but you should not be using them to solve every one of your problems. All right? If I ask to see your work and ask you to work it all out, which I am going to do for this units test, I'm going to ask to see all of your scratch work, then you cannot rely on Desmos, okay? You have to know how to substitute and how to eliminate, okay? You do have a Delta Math assignment to work on at this point.